Hello everyone. Hi, hello. Welcome to the channel. My name is Stefan Burns. Today we're going to discuss what's happening with the sun, like we often do here, because solar activity and sunspots have plummeted dramatically, really quickly. And there's a lot of reoccurring questions that people often ask about solar activity and when this solar cycle will be over. There's a lot of chatter about grand solar minimums. There's also a lot of information out there about solar maximum in general and how it proceeds. So we're going to take this opportunity to discuss what's happening with the sun and also, in general, kind of lay out the future of solar activity for, you could say, the next few years. We're going to look back at the historical record, and this is going to be a comprehensive overview. You will learn a lot in this video. If you're into space weather, if you like learning about this central engine of light and energy in our solar system, then you'll want to stick around and watch to the end. We may do a very fast Q&A, not sure. Regardless, let's get into it. We've had some activity over the past few days, but we have had kind of a marked shift in solar activity just in the past few hours, really. So we see a big filament blast off right there. That was, I think yesterday or the day before. I've kind of been out of commission a little bit doing some seismic data collection, but big plasma filament that blasted off. And you'll see all these bright regions over here. They've now rotated out, and effectively the sun has gone dark. Hi everyone, I see you all in the chat. Thank you all so much for being here. Welcome, welcome, welcome. If you're new to the channel, again, my name is Stefan Burns. We will go into it. One question that I will just posit for you. We're not going to go into this in this video, but I'll just offer you the question is, if the sun is the central engine of light and energy in our solar system, and it's really what keeps the whole solar system going, it's very much a macrocosm of what exists inside of us, our heart. We have our own biofield that the heart generates. It's the strongest magnetic field of the body by far. The sun is by far the strongest magnetic field in the solar system. Our heart keeps us going. It's constantly pumping. So is there a resonance between the sun and our heart? We see a ton of scientific studies that show that when there's changes in solar activity and geomagnetic activity, our heart rate variability changes, overall like heart rhythms and the power spectral density of the frequency rhythms of the heart, that all changes. There can be greater volatility with the heart when there's like strong solar activity and geomagnetic activity. So the question with that laid out is, if we are in this period of sudden solar quiet quiescent activity, just no activity, what does that mean for our own heart? And also the heart is the place in our body that carries all these emotions. It's our emotional body. It's very intelligent. There's neurons in the heart. It has in many ways an intelligence that exceeds that of the brain. It's different. It's not one-to-one. So if there is this resonance between them, how is that affecting perhaps our own individual hearts and our collective heart and so much more? So just a question I wanted to put out there at the beginning, but let's get into the heliophysics, you could say. And let's start off right away just by looking at the sunspot plummet. Here we can see back at the end of December, sunspots were over 250, and now we've gone down 80%. You would not want this to be a stock market chart. We don't want this to be the S&P 500 in the next year, because now we are down at 50. So you can see that we have these periods sometimes where we go down. Here we went down to 75, but then we went back up. But now down to 50 is really the lowest sunspot number that we've had in a long time, this being a daily value. So first and foremost, let's keep in mind that we're looking at a daily value. We're not looking at, let's say, a weekly or a monthly value. And a solar cycle overall, a Schwab cycle, there's multiple solar cycles, not just Schwab cycles, which are 12 years in length. That's the typical solar cycle that we think of, where the sun's magnetic field undergoes a polarity flip. So the North Pole changes, so the South Pole goes up there. You have positive and negative polarities flipping. That occurs about every 12 years. But there's other cycles. There's Gleisberg cycles that are about 88 years long, where you have changes over the entire like century-long time span, where some solar cycles will be stronger, then others will be weaker, and then there's even longer rhythms of solar activity. So it's important with a 12-year solar cycle to look at longer term measurements to get a sense of where we actually are in the solar cycle. But I know some people they look at a certain number and they think it's over. So yeah, it is very low right now, surprisingly low, I would say. If we go over to our latest 4K intensitygram, here's the Earth facing side of the sun right now. You'd be hard pressed to find any sunspots, and the ones that are there are pretty tiny. Maybe we can punch in on that guy. You're not going to write home about that one. Nothing really here is all that exciting. We had quite a lot of sunspots just recently, but they've rotated out, and now we're left with this blank slate effectively. And so this is what the sun looks like during solar minimum. The difference is that the entire sun will basically be devoid of sunspots during solar minimum. And if you do get one, it'll be some little guy like that typically. I mean, there's some variability with that. You may get one, kind of larger sunspot to appear during solar minimum, but typically the sun is quiet, the polarity is stable. So do we have a stable polarity with the sun right now? No, we do not. We are still in solar maximum. We are just in one of these quiet periods. In fact, we do see that occurring with solar cycles across time. We can look at a solar cycle progression. We have a lot of data to go through. We have our solar cycle progression here, and we see, going back to solar cycle 23, some trends. So here's solar cycle 25 right here, and you can see the original NASA prediction. There's a kind of a coalition prediction that they came out with in 2019, 2020. Thank you, Marie, for the super thanks. And so we see it going up here, actually exceeding their expectation, which was akin to solar cycle 24. We see that they thought it was going to be similar. They based this prediction, the original one, off of the polar magnetic field strength during solar minimum. And since it was effectively the same as it was in between solar cycle 23 and 24 at this period right here, they thought it was going to be another weak cycle. You can see the longer term solar cycle variations down there. We'll zoom in this way a little differently in just a moment. You can see that we're actually riding above the 1 standard deviation mark the entire time, and we're actually well above that. But that's just the old prediction. But you can see that we're at a pretty high point here. And so this is solar cycle 24. Sunspots never got above 150. That entire solar cycle. Here's 23. We're more like solar cycle 23 right now than we are 24. But in reality, we're kind of a blend of both, because as of right now, solar cycle 23 has still been slightly stronger than 25, though perhaps we go up again. We just don't know. What we see with these two solar cycles, though, which is interesting, is that they have these ramps up at the beginning, and then they take this dip in the middle, and then they go back up again before descending down. We see that also at 24 here, a little bit of a longer solar cycle because it was a weaker one. Typically, the weaker the solar cycle, a little bit longer in time duration, whereas it's a strong cycle, it's a little bit faster in time duration. So we see this spike up there, then this lull where sunspots were consistently under 100, and then it went back up, nearly got 150, and then started going down. So if we go back to our daily sunspot graphic here, we see our blue line there, actually our average. So that's important to keep in mind, because see here, back in early January, we were at 200. Then for a long period just recently, we were above 150 and getting close to 200. You see that spike right there. So our monthly sunspot number is just under 150. That is one of the lower values for the recent few months. We can check that out. And if we zoom in specifically on solar cycle 25 here, then we can see that. So here is our high mark for sunspots in August 2024, right there, about 216. And we see our most recent values there, 152 for November, 154 for December. We did have a 141 value for September coming off that high in August. So it looks like we're going to be settling just below 150 for January, which is basically very much still in solar cycle 25 maximum. But one of the reasons I wanted to make this video and I wanted to grab people's attention is because there's a lot of just, I guess, poor journalism as it relates to the sun and this solar cycle in general, because I see a lot of articles out there, a lot of videos, and a lot of people commenting saying solar maximum is over, or like solar maximum has occurred. Like it's a temporary, one-time, one-day, one-week event. And that's just not the case. As we just saw with the past 2 solar cycles, and we'll zoom out to some others, it's like a 2 to 3 year long period. So for this to like suddenly plummet down and like completely terminate and go to solar minimum would be very bizarre. We don't see that in the record. This is like 2 to 3 years long. We're still just at the early middle phase of solar cycle 25 maximum. And what we're seeing right now with our daily sunspot count is a rhythmic trend. We're seeing that it just happens that the sunspots on the Earth facing side have totally rotated out. And if I change the graphic to a different slide that I made, where did those sunspots go? Well, here we have our far side map. This is helioseismic data. It measures the like vibrations of the sun basically. And it's very low resolution, but it can tell you where there's different sunspots or just regions that are more active. Outlined in red here is our Earth side. This is for January 27th. So it's already about 24 hours out to date. Just keep that in mind. But it works for here. January 27th, we see basically no sunspots with our helioseismic. We already saw the intensity gram. Here again is our daily count. We see that's about 50, just about 50, maybe 51. Look at our far side though, completely covered with sunspots. And not just one big group here or a group there. The entire 180-degree stretch basically on the far side is filled with sunspots. And you'll notice actually one right there also shows up right here that is about to rotate into lopsided right now with the sunspots. All the sunspots are clustered on one half of the sun. Of course, the sun's rotating. We're also orbiting around it. And so right now, today, we just happen to be perfectly aligned with that quiet side of the sun. So if you are solar energies, this is a very important data point to take note of like how you're feeling with the fact that right now things are very quiet. Because we look at solar flux up here. This is a 2800 megahertz radio wave. It's in the radio microwave spectrum. It's actually same frequency as 5G. That is emitted from the sun all the time, and we can measure this with solar flux units. We see this peak here, end of December, above 140 going up to 260. Then we see it go down here. This was right there at the beginning of January. Middle January. Is that right? Yeah, beginning and middle of January. Then we went back up again when we had that big right there, this peak of sunspots, and then we're back down to 160. But what solar flux really shows nicely is that there's a stable amount of energy emission that comes off the sun, and that does go down more during solar minimum than maximum. But even during solar maximum, with no sunspots on the Earth-facing side, we still get a relatively stable value there, 160. Whereas here, sunspots were more like 70. Here it's 50, but we see it's the same solar flux value. And if we go back to our solar cycle progression, but this time we look at our radio flux, the same wavelength of light, 2800 megahertz or 10.7 centimeter wavelength, we see here how much low during solar minimum. So if I really zoom in here like this, we can see that during solar minimum, the solar flux value for that specific wavelength, they measure a few of them, about 70 or lower, whereas right now we're hovering at 160. And we even see here for the high, the monthly high for August was 245.6. And that can vary across the different solar cycles. This one just shows going back to solar cycle 24, where we see it never went really above 170. 170 was the top value that it hit in February of 2014. Now, if we go back to our solar cycle number progression, our sunspot number progression, we'll see a few different things. It will give us a sense of the variability in a solar cycle. It'll also give us a sense of just the fact of how long they last. Because again, the fact that like there's a news article that comes out and the person did 20 minutes of research before writing it for some website, I don't know, science.com, whatever, right? They make solar maximum sound like a instantaneous, we're moving on. It's like a 2 to 3 year process. We see that here with our solar cycle progression. This goes from all the way from solar cycle 13 to 25, and we see all these are like 2-3 years long, right? Probably about 3 years on average. It's not like you just hit a high point and then go down from that. We can zoom in here on 19, which is the strongest solar cycle that we've had in a couple centuries, with sunspots going all the way up to 359.4 in October of 1957. We had a big ground level enhancement in 1959 or 1956, one of those 2 years. Look at that though. It's a big, big, big long duration period here. This is the ascending phase right there, and this is probably right about there is solar maximum, and then you start to have the descending phase, right? So you can look at our dates right there. This is all, a pretty long duration of time. Hit that peak, August number of 215 sunspots. It's not like you hit that peak and solar maximum's over. No, that's just the peak of a long wave of activity. So that is what we are seeing right now, but the inverse. We're seeing just a trough, a sunspot number low, just a daily count. I don't think so though, because if we go back to our intensity gram, we will see right up here something new coming in. Remember our helioseismic data showed something about to approach, and we're already seeing a pretty big sunspot appear on the eastern limb. And when it's on the limb, it gets really squashed and it's hard to see. So we really can't get a good sense of what this sunspot looks like until about 4. But specifically, if we go to our magnetogram, we get a better idea because we punch in on that and we can see that it is very, very strong in its magnetic field as compared to just the rest of the sun right now, which is very quiet. So we see some pretty strong magnetic fields right here in the northern hemisphere, soon to rotate in. And we also see some other activity. Once you go to the magnetogram, you can see that, there's still some activity on the sun. This is all corresponding to bright regions, but the magnetic fields are not that strong. This sunspot group that's rotating in is definitely the strongest already on the Earth-facing side, and it's just started to rotate in. So I will keep track of that, keep you up to date. If you subscribe, then you will get all that information. Now, I want to go back to our solar cycle progression because I want to look at solar cycle 14 quickly, because this is an interesting one. I just saw this today. I may have looked at all these, but I just noticed the weird trend with 14 here. But if you notice at the bottom, we actually had, this lull period right there where solar cycles were weak in terms of their sunspot numbers. Then we had this high period, and then we also had this other kind of lull period. And that's just what we came out of as solar cycle 24. So we had a lot of activity here. This modern maximum is what they call it. And then we kind of dipped down in 24, and a lot of people thought, not the official forecasters, a lot of people thought that we were just going to completely flatline into a grand solar minimum, just like the Maunder minimum back in the late 1600s and early 1700s. Well, that's not the case. It's definitely not a grand solar minimum because, again, we can look at our sunspots and see that they've been quite high. Like, this is not a weak solar cycle. We've had numbers right around the average for a solar maximum, sunspot 175. That's the average like for the solar cycles across time. So we're at that average. But if we look at 14 here, we see that it followed solar cycles 12 and 13, which were kind of similar to solar cycle 24. We see these values here in the same range. They did get higher at times than solar cycle 24, which never got to so across time. So that's very important to keep in mind. Now, one thing I'll note is that in the future, we'll be counting sunspots on the sun differently, because right now we only count the sunspots on the Earth-facing side. But if we can get some probes around the sun and have complete coverage of the sun, then we should be counting and monitoring solar activity from a more comprehensive 360-degree look and looking at sunspots across the entire sun at once, measuring solar flux and kind of creating an average for the sun, all at once. That would be a much more precise measure of solar activity than what's happening right now. Because, for example, as I touched on, Earth-facing side of the sun, quiet, whereas the far side here is loaded with sunspots. And so we're not accurately catching the true representation of comprehensive solar activity at this moment in time by just looking at the Earth facing side. Let's look at this plasma filament that blasted off because it was pretty nice. This is a really nice plasma filament launch that we just had. And I'll let you watch this. That is also something that you typically won't have during a solar minimum. What we're seeing here with our 304 angstrom view is effectively a lot of magnetic flux across the sun. What you have with the solar cycle is you have during the minimum very strong magnetic field polarity up here and down here, and you don't have any magnetic field lines coming out from the lower latitude regions. Nice clean magnetic field, and then there's no flux in the center during minimum. And there are sunspots, because sunspots are a symptom pushing out of the sun. Well, what we see here, even though this is a fairly quiet sun in terms of sunspots, when we're looking at our photosphere, we see this plasma filament launch. That's all indicating that there's quite a lot of magnetic field strength coming out from these mid-latitude to equatorial regions on the sun. And that's what happens during solar maximum. You have the magnetic field flip. It's most chaotic, and you have all these field lines coming out with different polarities in all directions. And so you get things like this plasma filament launch off because of like a magnetic connection, that occurs. Positive negative polarity meet, all of a sudden releases that energy, and you just get this destabilization of the plasma. You get things like solar flares. We can look at that really quick. We did have a last flare just recently, but it wasn't anything to write home about, but we did have it. And we'll see it here in the Northern Hemisphere, actually from that new sunspot group that's rotating in. So there's that plasma filament launch. Doesn't show up nicely in 131, but we'll see this solar flare here soon. This occurred today. An M2.6 flare. So you have things like that happen during solar maximum, whereas you very rarely will get any sort of M-class flares or X-class flares during a solar minimum. It's possible. Again, you need the sunspot to do it, but we get them quite often during solar maximum. We're just in a temporary quiet period as in time. As active on the sun right now. That is another indicator that, yes, we are still in solar maximum, is the coronal hole on the sun and the location of the coronal hole. During solar minimum, you will have coronal holes in the polar regions. Now, they can spread across the sun. They can get really large during solar minimum. This area of dark plasma, lower temperature, open magnetic field, particles streaming out. You'll have that more clustered in the polar regions during solar minimum and also the maximum, just like the sunspots and the solar flares and all the activity. It migrates to the equator, and what that's called, it's called a termination, because you have these bands of magnetic flux on the sun, and they slowly move like this, and when they meet, they then equalize each other out, and you get the new polarity establishing. So when they're still in this mid-latitude but close to the equator zone, that's indicating that we're very much still in solar maximum. It's not until they get to the equator that you know you're on the descending phase and going to solar minimum. And that's very nicely demonstrated with our butterfly graphic. So we can look at our butterfly diagram for quite a few solar cycles right here. And this goes all the way back to solar cycle 12. This is where you can find this graphic, solarcyclescience.com. And we're looking at the sunspot area coverage in 50 equal area latitude bands. So we kind of split the sun into these 50 equal area latitude bands. And we have a thing right here that shows us, the color shows us like how much of that band is occupied by sunspots. And so we see that you start the solar cycle with these sunspot coverage, lower percentages, and also at higher latitudes in both hemispheres. And then as the solar cycle progresses, the sunspot coverage percentage goes up and the latitude location of those sunspots goes down, and then when they reach the equator, you see that they almost reach the equator before the solar cycle then tapers out, and then sunspots re-emerge, high up in the hemispheres, closer to the poles. That's called the race to the poles. If you read these research papers, that's what they call it. So you have the magnetic flux all of a sudden, like within just like a month or two, race to the poles, and you have the new solar cycle start, but it takes them a while for them to start to really move down and the new solar cycle to like progress. And so solar years. And then you have the ascending phase, which is like each one into 3 years. Ascending phase, 3 years, maximum 3 years, descending phase, 3 years, minimum 3 years. That gives you 12 years, and that's basically the average length of a solar cycle. So here's solar cycle 25. Look, we are still very much, pretty much in the middle of this. I mean, we're not gonna have a solar cycle, very unlikely we'll have a solar cycle as strong as these guys right here. We see that, 19 here was a monster. But you can see that we're still quite, I'd say about one third the way through this butterfly diagram for solar cycle 25. So we have maximum and then also the descending phase, right? This is also showing the descending phase and also the minimum. So we still got quite some time with this all the way through 2026, I would say, for solar maximum. The things may start to go down. And then we have phase going probably all the way out to 2029 or so. If we go back to our display capture, I want to go back to our solar cycle progression because we can just see some of the variability. We can just kind of zoom through this a little bit to give you a sense of how these solar cycles vary across time. So we go here and I'll kind of position off as best I can for you. And yeah, so we don't have the most data that we would like. That we only have these numbers going back to like the 1600s, 1700s. Counting sunspots, solar flux is a recent data that we've started to collect. But we see how there can be variability. I mean, look right here. Solar cycle 15, went up, kind of plateaued, had this big spike and only went down from there basically. Just some very transient increases, but not a long sustained push. Whereas solar cycle 19 really got up there, stayed up there. If we go over here, look, over 200 for a long duration of time, did have a peak over 300 before going down. Solar cycle 20 went up and then kind of held for a while, then like hang. And so we see trends across the solar cycles. Here again, kind of going up, plateauing, spiking up from there, and then kind of settling down afterwards. You see that the ascending phase often is longer. There can kind of be like this momentum or just drag viscosity, you could say, to the descending phase. Here we have some periods of really low activity, 5, 6, 7, right? Sunspots barely broke 100 for just a couple months there in 5. And if we go here, we see an absolute monster sunspot or solar cycles, solar cycle 3, where we had a spike up to about 400 there. And sunspots well over 200 for a long period of time. You can see solar cycle 4, look right next to it. Super long, just gradual decay from that solar maximum phase right there. So these solar cycles come in a variety of flavors. And so just important to keep in mind that we are going to experience not only variations with the sun across time, like this is a short time scale, but also variations in solar activity across the solar cycle itself. And that our solar cycle 25 so far has actually been quite stable in its sunspots. If we go back here, really punch in on it, and we can even, let's do this. We see that we went up here, we had some volatility, but actually we kind of held a fairly stable range before going up, and we've still been holding a fairly stable range. And if we go back to our daily graphic, let me show that. Yeah, here we go. If we go back to our daily graphic, see that our average for the month thus far, January, is still just below 150. So it's not 100, it's not 80, nothing like that. We see that we're still quite up there. This number for January will be slightly lower than these past two. It probably will be similar to what we have right here in September, which is 141. because we do have new sunspots now. New sunspots now about to rotate into view. Let's see what else. Oh yeah, so another thing too. People will often also think that this solar maximum is kind of one and done because of data like this, and they're not really interpreting it correctly. So here we have a variety of different cycle forecasts. A lot of these graphics are from the Royal Observatory of Belgium. All the data is linked in the video description, at least the NASA, the NOAA, things of that nature. So we can go here, we can look at our standard 12-month forecast. We'll just go through a variety of them. They all look fairly similar. Here we see this one. Here's the numbers that we have, and here's the forecast of prediction. You see that starts to go down, right? So all of them are showing a gradual decay of the solar cycle after this point in time. I'm not, saying any of these are going to be accurate. These are all just models. I think it's probably actually more likely that we'll have a second peak and then go down at some point, like solar cycle 24 and 23. We'll see if that trend continues. But you're seeing that this one's going down. We can go back. We can show the next one, just a different graphic. You see it going down. Look at this other one right here. We can see it also going down, but you'll notice none of them are just plummeting like this. If solar maximum is really over, it needs to be over. You need the magnetic field to flip. That's not showing this. This is showing a broad duration solar maximum. These are all just forecasts, but even if solar activity and sunspots are going down, doesn't mean that you're out of solar maximum. So please keep that in mind. We could very well have a peak again in solar cycle 25. I would not be surprised if this kind of hovers around this 150 level and then we get some spike in 2026 or even late 2025. I could see that happening. I could see that really happening in February. Don't hold me to that, but I could see that happening around January for January through April of 2026. I could see that being a high point. I'm not going to tell you why I think that, but I could see that. So that's just kind of what's happening with the sun right now. We also can look at some of the recent chronograph imagery because this is pretty cool, and also shows you that there has been some activity, but it just hasn't been Earth directed. We've actually had a whole bunch of solar storms basically miss Earth, which is kind of weird. I'll talk about that just briefly. But we have our chronograph here going back to the 24th. And let me actually pause this and go back because we'll see at the very beginning a mega flare. That's not an official term, but it just blasted off super high velocity, did not hit Earth. It was about 7 days early. And we see that show up on the chronograph really rapidly and then expand out high density. Look at that. You don't really get that during solar minimum. And then we had that plasma filament launch on the 26th. So we'll see that soon. So there it is. And we'll actually get two more puffs from that. See another one and then another one. So we've actually had some solar activity, but it hasn't been Earth directed. So we go here. And we'll go back to our 304. And someone's saying that the stream health is not good. Okay. Let me get set up again. We'll see these other puffs too. They're not as obvious, but you see these kind of other emissions from the sun afterwards, following. So we have continuous activity from that group, and we have these new sunspots rotating in. So we could, over the next couple of weeks, start to see solar activity start to ramp up. It's almost certain that sunspots are going to climb up again with this guy rotating in there. It just had that 2.6 M-class flare partially eclipsed by the sun, so it was likely a stronger solar flare than what we saw. Be rotating in soon. So don't forget that those have high-speed streams, and that could also enhance solar activity over the next week or so. If we zoom forward, we really can see those coronal holes right there. These will be sweeping through the geoeffective position and may give our magnetic field a little rattle if they do. So yeah, that is what is happening with the sun right now. And I just wanted to do this live stream to keep you all up to date because yeah, we've had a big drop in sunspot numbers. So I guess there's been some problems with the live stream. I don't know why, but I hope that you all saw this as much as you could. It cuts off. It's starting getting choppy.